topic is the real number system. The essential question is, how are all real numbers categorized? And what's the difference between rational and irrational numbers? So I want to start off by telling you that in 7th grade, we're just going to be talking about real numbers. In the future, you'll learn that there are real numbers and imaginary numbers, but I don't want to confuse you with any imaginary numbers just yet, okay? So anyway, all real numbers are classified as irrational or rational. A number cannot be both irrational and rational. It's either this one or this one, okay, if it's a real number. So anyway, we'll start off by talking about irrational numbers. These are numbers that you cannot rewrite as a fraction that's made up of two integers. Okay? Now this whole part where it says that you cannot rewrite them as a fraction that's made up of two integers, okay, that's really, really important. And we'll talk more about that later, okay? So when irrational numbers are written as decimals, they're non-terminating, which means they go on forever. And they're non-repeating, which means there's no pattern. So here's some examples of irrational numbers right here. Okay, so you see the square root of 2. I'm going to show you on a calculator the square root of 2. And I'm going to show you how it's irrational. So right here I have the square root symbol. I'm going to go ahead and put a 2 in there. And you see what we get? We get 1.4142135623730. Okay? And it's only going to be this big simply because my calculator is not, it doesn't go on forever. So look at this number right here. And remember the irrational numbers, when they're written as decimals, they're non-terminating, so they go on forever. And they're non-repeating, so there's no type of pattern in there. So the square root of 2, that is an irrational number. So just to remind you of what they would look like as a decimal, I have this approximation sign right there. So it's approximately 1.414213, so on and so forth. It goes on forever, okay? See how this decimal is non-repeating and non-terminating. Okay, now we have the negative square root of 5. Put the negative sign here. Find my square root of 5. And look what we get right there. Again, it's a non-terminating and non-repeating decimal. So therefore, the square root, or the negative square root of 5 is irrational. Okay, and then right here I have pi divided by 2. And I want to redirect your attention to this statement up here. Irrational numbers are numbers that you cannot rewrite as a fraction that's made up of two integers. So you look here and you're like, well, that's a fraction, isn't it? But this pi right there, that is not an integer. So therefore, pi divided by 2 is an irrational number. And when I take pi and divide it by 2, I get approximately 1.570796327, so on and so forth. And again, its decimal form is non-repeating and non-terminating. These are irrational number examples because you cannot write them as a fraction that's made up of two integers. Okay? Now we'll move on to the other classification of real numbers. You remember how all real numbers are either irrational or rational, and they can't be both? So if it's not irrational, then it's going to be rational, okay? And these are numbers that you can rewrite as a fraction that's made up of two integers. But there's a key thing. 0 cannot be in the denominator. So when you rewrite it as a fraction, if there's 0 in the bottom part of the fraction, you know, the denominator, that's not going to work because you can't ever have 0 in the denominator, okay? So here's some rational number examples. You'll see I have bullet points right here because there's certain words that mean these types of numbers. So natural numbers, those are rational numbers. And here are examples of natural numbers. 1, 2, 3, 4, 5. And that continues, okay? Those are examples of natural numbers. You'll see that they're positive whole numbers, okay? But 0 is not a natural number. Then other examples of rational numbers are whole numbers. And this is just like natural numbers, but the only difference is they added 0 into that. They consider 0 a whole number. Okay, now comes integers. Integers are any whole number and its opposite. So it'll continue this way, because I obviously can't list them all. 0 is an integer. Okay, so it's any whole number, see these up here, and their opposite, so 2 and -2, okay? All right, if something's already written as a fraction, it's automatically rational. If it's already a fraction, it's automatically rational. So it's fractions in any form, like 1/2, -1/4. I'm not putting these in any particular order. 2/3, -4/7, 1 4/5, 9/7, okay? Etc. So if it's already in a fraction, it's automatically a rational number. I repeat, if it's already written as a fraction, it's automatically a rational number. So I want to show you an example here. When I go 9/7, 9 divided by 7, this is what I would get to get its decimal. And you're probably like, gosh, that looks irrational simply because it's non-repeating and it seems like it goes on forever. It's non-terminating. However, since it started out as a fraction, it's already written as a fraction, that automatically makes it a rational number, even if it looks like this, okay? Now with these examples over here, we are not able to write those as fractions composed of 2 integers. So that's what makes these decimals different than this decimal. This decimal I'm showing you right now, it started out as a fraction of 9/7. And although it looks like it would be irrational, since 9/7 is a fraction, this right here, 9/7, is a rational number. Okay. Other examples of rational numbers are terminating decimals, such as like 5 and 2/10, because you can write that as a fraction. 5 and 2/10 is written like this, 5 and 2/10. See, those two are equal to each other. And remember, when it's a fraction, it's automatically a rational number. Let's try another example. 25/100. Look, that can be written as a fraction, composed of 2 integers. So it's automatically rational. How about -7 and 40/100? That is also rational because we can rewrite it as a fraction made up of integers. It'd be -7 and 40/100. Let's make up another one. How about 9 and 360,000ths? Here's what it would look like as a fraction. 9 and 360,000ths. They are called terminating decimals because they don't go on forever. They just stop. Okay? All right, and last to the list of rational numbers are repeating decimals. So I can think of 0.3 repeating because as a fraction, that's 1/3. See? Another example would be -0.6 repeating. As a fraction, that would be -2/3. Okay? And something special about these repeating decimals is they have a pattern. So when I typed in 1/3 into my calculator, you'll see that it's a repeating decimal. It's non-terminating. It goes on forever, but look, it's got a pattern. Okay. And I'm going to show you another example of a repeating decimal. Let's say 0.45 repeating. So that pattern would repeat. Okay. 0.45454545. And as a fraction, that would be 5/11ths. So when I had typed 5/11ths, 5 divided by 11 into my calculator, you'll see that I have 0.4545 repeating, and that goes on forever, and when it goes on forever, it's called non-terminating, but you'll see that it is repeating. It's got a pattern. So that's what makes this, in its decimal form, a rational number. I want to remind you, if it's already in fractional form, then it's automatically a rational number as long as the numbers composing that fraction are integers, okay? So all of these right here are rational, whereas this one over here is irrational because pi is not an integer. Now for your summary, I want you to go ahead and answer this question. What are the two classifications of real numbers? And in addition, I want you to classify the following numbers as rational or irrational. So the square root of 16, is that rational or irrational? Square root of 6, would that be considered rational or irrational? 4/8, is that rational or irrational? 5 7/100, is that rational or irrational? And then pi divided by 6, is that rational or irrational? Okay, I want you to complete the back page, and here are the instructions. It's a follow-up activity. I want you to classify the following real numbers as rational or irrational, and I want you to place them in the corresponding box. So right here I have the square root of 4. Would that number be rational or irrational? 3/6, go ahead and categorize it. 1 5/10, 0 divided by 1. The square root of 2, 9/10, the negative square root of 3, the negative square root of 4. Classify them in their proper boxes, and please remember those definitions that I just told you about regarding rational and irrational numbers. And if you're curious, they're right over here on the previous page, okay? Okay, I'll go ahead and do one example with you. I see the first example right here is the square root of 4. And if you don't know the square root of 4, you can just type it in your calculator. I have the square root button right there, square root of 4, and that is 2. So 2, since that can be written as a fraction composed of two integers like this, I know that the square root of 4 is a rational number, so I'm going to place that right here, okay? So you're going to do that for each one of these examples here and place it in their proper boxes. After that, you'll take this number, or that number, you know, it's the same thing, and place it on the number line. Well, since the square root of 4 is 2, I'm going to go ahead and align that in a column right there, okay? After you're done placing all those in their boxes and on the number line, you're going to go ahead and answer this question.